Welcome back to the bench. Today we're going to be attempting to fix a Jbl Gto14001 amplifier. This came to me from a buddy of mine. He had tried to make some repairs on it. I think he found a MOSFET blown in the output section, and I think he tried to take it out and see if it would work, and it kind of somewhat worked, but there was some other issues, so we brought it over here and we played with it for a little while on the bench, and we had come to a decision, or come to a conclusion that there was a problem with one of these driver boards. There's 4 FETs for each side, and we found that a set of 4 FETs wasn't getting any gate drive and another set were. So we're assuming that the problem is coming from the gate drive IC on one of these boards. So we're going to I'm going to show you how we found out that we weren't getting any gate drive, and we're going to go from there. And I'm assuming we're going to be changing this IC out. I did a little bit of SMD work on 2 resistors that burnt out, and on this particular model here, they're stacked together, and we tried to do it without taking the whole amplifier apart. We just tried to change the resistors to see if that would make it come back alive. So it was kind of, tough to get in there, so it's not a pretty job, but we were trying to just verify that the IC was gone. So we're gonna go through and test this and try and bring you up to speed and how we got to the point where we think we're gonna be changing this IC out. So what I'm gonna do now is I'm gonna cut to showing you how we're going to be testing these gates. There's a low drive and a high drive on each set of 4. So we're going to be testing those and see if we get them, and if we get them on one and not the other, and we'll go from there. Okay, so here's a full shot of the amplifier. It's a pretty nice size amplifier. It's a Class D, and this thing is got some nice power behind it. The section we're working on is right in here. This is the output section, and these are the 2 boards. You might not be able to see them, but they're the 2 driver boards for the FETs. Right now I'm on the known working channel. We're going to be testing the gate of Q23 and gate of Q26 and see what we get. Let's go back to the other camera here. Alright, so I'm on the gate of Q26, as you can see right here on one probe, and the other probe I have on Q23 on the gate, which is right here. And we're going to turn this amp on and see what we get for drive. So let's go to the other camera and let's get this out of the way temporarily and see if we can get the scope in the view. Alright, so now I'm going to turn the amplifier on. She started up, and we have gate drive, and we heard some clicking. I think the protection relays kicked on. I think that these are the speaker output relays, and they are kicking off, on and off. So there's something definitely wrong, but we're getting our gate drive on this set of 4 on the right side. So I'm going to unplug it and shift over these probes to the other gates on this side, and we're going to see what we get. Alright, so now I have just shifted over to the other set, and now we're on the other board here. So let's go and try turning it on and see what we get out of that. Absolutely nothing. We're not getting anything out of this. So in fact, we have no drive on the gates on this set of 4. So now we're going to be looking at this board over here. These 2 boards right here. One set is for driving this 4, and I believe the back board here is driving the left 4. So we're going to have to strip this amplifier down at this point and try and remove this PC board to remove this board and pull these FETs out, because he gave me a set of FETs. He wants to just change them all. So that's what I'm going to do. We're going to change all those FETs, and we're going to try changing that IC on this board. As you can see, there's probably like half of an inch between these two boards, and I had to get in there and try and change two resistors at an angle, so it was not fun, two SMD resistors. So that didn't turn out to fix the issue, so we're going to be definitely replacing that IC, and we're going to replace all these FETs as well. Let's go back to the microscope here. I believe he tried changing the FETs without pulling the board for testing, so I think that's why we see a lot of this build up here on all these parts, because I believe he pulled them all to test to find where the shorted component was. So we're going to end up pulling all these FETs out and cleaning all this up, because at this point I think we've diagnosed the problem and we're replacing parts. So I'm going to start stripping this board down, and it's just going to be a matter of pulling all these screws of all these MOSFETs and pulling the side plates off and any screws that might be attaching the RCAs or the power side, and hopefully this board will come straight out, and we'll be able to remove this board. Okay, so I have the amp board out, and we're going to be removing this module here. I'm just going to be using my desoldering gun. Let's see if I can get in here with the microscope. It's kind of a tight fit. Move this over, get the other side of the board. I have to go over a couple of these. All right, those are desoldered. I may have to do a little bit more work on that, but I will get the board out and we'll come back and take a look at it. All right, so I've pulled that board out, and this is the module. Just got to unsolder these pins from the board, and this is the IC that we're going after. And I've got one here to replace it with. I am hooked up to my ESD workstation, so we're good there. I'm just going to put some flux on these pins. Let's turn the air on. Just like before, we're just going to preheat the board a little bit, let that flux melt. Stay a little bit further away. Try to get everything up to the same temp. Okay, I'm going to get a little bit closer now. Okay, we're starting to melt solder now, so I can come in a little bit closer and go for the removal now. There we go. Alright, so we're going to let that cool for a second. And we're going to go over this with our soldering iron and some flux. And get those pads nice and wet again. And remove all the solder. Let's cut this end off. Do the other pins. Looks pretty good. So now we can clean it. Throw a little bit of alcohol on a toothbrush. And we'll there we go. So now we're going to be putting down the new IC. Before I do that, I want to put a little flux down. Straighten this out. Looks pretty good like that. So now I'm going to swap my tips over to a curved tip. Let that heat up for a second. And it looks like we may just have to go just a hair to the left. That's pretty damn close right there. So we'll tack the one leg down. Put some dab of solder on the iron. Well, that was a big solder blob there. That was not good. Alright, so let's tack the other side down. Okay, I'm going to remove that little bit extra solder there. That's what I want it to look like. Okay, so now we'll heat that other side up just to make sure we're nice and stuck there. Beautiful. All right. So now we can solder the rest of the pins. Hit the bottom row. And that's it for that. Now we'll just see if we can get this cleaned up a bit. It looks pretty good. All right, let's put that in and let's give that a shot. All right, so I'm just soldering in the new FETs now. I've already taken the old ones out. There was a few damaged pads, but I think we can work around those. These are through-hole vias, so anything that's damaged we can get on the other side. So looks pretty good. I'm just going to go through and continue on, and we'll come back when they're all set. All right, so we have the new FETs in, and everything's installed. The board's back in with the new chip, and the FETs have been reseated and re-greased. All the other parts have been re-greased too. So we're going to be testing the known good gates on this side, and then we're going to swap the probes over to the side that was bad and not working and see if we get drive signal there. So let's power it on and see if the good side works. All right, look at the scope here. We're looking very good here. All right, so happy there. So let's turn that off and go over to this side. And see what we get. Bingo. All right, we're good. We are out of protect. We have our blue light. The red light is out. Yeah, I think we're ready to throw a signal through this thing. So I have the generator now hooked up, and I got the speakers ready to go. I'm just going to do one at a time to make sure we have signal out of each channel here. Let's turn this generator on. Turn the amp on. Yep, and she's lit. All right, let's try one channel first. Ooh, good. I'm gonna take that off, try the other channel. We're good there. I'm gonna hook both of them up now. I have these hooked up to a set of 12s right now, so let's do a little sweep here. This thing has an EQ built in it, so there might be some dead spots. Let's see, modulation. Wow, this thing's shaking the room here. So that's good. We'll shut this off. Everything's staying nice and cool. These Class Ds, pretty efficient. Haven't had it on long, so. All right, so we got another win on the bench tonight. This Class D Jbl 14001 amplifier, Class D, is repaired. We've replaced that IC on that board for the drive of the FETs, and we've replaced the FETs, and I've replaced some of the insulators because one was missing, and I've Loctited all the screws down. We gave it a test. Everything seems to be working well. I'm going to beat it up a little bit later under a load, and that's about it. I think this thing's ready to rock and roll here. I don't see anything else wrong with this, and that's about it. So I hope you guys enjoyed this video repair on this amplifier, and if you like what you see, hit the subscribe and like button, and come back later and we'll have some more repairs to do, and we'll see you in the next video. Have a good night.